Hi children, so how are you? I hope you are fine, enjoying with online classes. So I am KC Hubadi, PGT Chemistry, Jawahar Navodaya Vidyalaya Uttar Kannada, Karnataka State. So children, you might have learnt in different subjects, different topics. Now in science, you have 4 chapters in chemistry. One is about matter in our surrounding. Second one is matter around us pure. Third chapter is about atoms and molecules. Fourth chapter is about structure of atom. I hope you have studied the first chapter, that is matter in our surrounding. Now in this class we will be learning about is matter around us pure. See, often we use the term pure substance and impure substance. What's the meaning of the term pure substance and impure substance? And how are they classified? What are the properties? All these things you are expected to study under this chapter. Is matter around us pure? As I told you, I am KC Hubadi, PGT Chemistry from Jawahar Navodaya Vidyalaya, Uttar Kannada. This is my school. So, you have studied in the last chapter, that is about the matter. What is matter? You have studied. So, classification of matter, little bit idea you have there. So, matter you have defined as a matter is anything which has mass, occupies space and offers resistance. So other details about the matter you have studied, it's a continuation of the same only. So classification of matter and other things you have studied. So matter is broadly classified into 2 categories. One is about pure substance, other one is a mixture it is. So in the pure substance we have 2 classification once again. One is elements and another one is the compounds. So what are elements? The question arises there. The elements are the substances which are made up of only one kind of atoms in it. For example, gold, silver, platinum, etc. They are all made up of only one kind of substances. So whereas compounds are the substances which are made up of one kind of materials in it there. So same composition will be there in that. Say for example, water is a compound, sugar is a compound, common salt is a compound, etc. The different elements which are composed of in that compound are in fixed proportion only. So other classification in that matter is a mixture. Mixture is a one which is made up of 2 or more substances there. Again there are 2 types of mixtures. One is homogeneous mixture and another one is a heterogeneous mixture. Homogeneous mixture, what's the meaning of the term homogeneous mixture? Homogeneous mixture is a one which is made up of substances which cannot be distinguished further. Heterogeneous mixture is a one which is made up of 2 or more substances in which the components of that mixture can be distinguished. So, pure substances and mixture. So, pure substances are elements and compounds, and mixtures are of 2 types. So, homogeneous mixture and heterogeneous mixture. So, basic difference between pure substance and mixtures are these. So, pure substance consists of single type of substances, whereas mixtures consist of 2 or more substances there. So, pure substances cannot be separated by any physical means, whereas mixtures can be separated by some physical methods. Pure substances has its own properties, definite properties they have, whereas mixtures have the properties of the component particles present in that. So, we have the term come across there, true solution. What do I mean by true solution? True solution is it is a homogeneous mixture of. True solution is a homogeneous mixture of 2 or more substances. 2 or more substances when they are mixed and gives this homogeneous mixture. That homogeneous mixture of 2 or more substances is what we call it as a true solution. So question is, already we have seen homogeneous mixture is the one, the components of it cannot be distinguished. So, and that you have the salt solution, sugar solution, a solution of tincture, wherein the sugar solution, when you add sugar, prepare a solution of that in water, you cannot distinguish between the sugar particles and the water. Salt solution, salt and water when they are mixed, so the components of it cannot be distinguished. Tincture of iodine, so iodine in the mixture of water and alcohol is what we call the tincture of iodine. When the mixture is formed, you cannot distinguish between iodine, water and alcohol. So what are the properties of this true solution? So true solution has these properties. True solution is a homogeneous mixture. The particles cannot be seen by naked eyes. The solid particles can be separated by filtration. Solid particles do not settle down. So if we keep it for some time, the particles do not settle. The particles do not scatter the light when it is passed through that solution there. Okay, take in a beaker sugar solution or salt solution through which you allow a source of light to pass through it. The particles present in that do not scatter that. Scattering effect they do not exhibit. So this is about the true solution. So another one is suspension, the colloidal solution. We will see the colloidal solution. Colloidal solution. What is a colloidal solution? Colloidal solution is a heterogeneous mixture in which the particle size will be in between 1 to 1000 nanometer there. So in case of true solution, particle size will be less than 1 nanometer. So in case of colloidal solution, particle size will be more than 1 nanometer and less than 1000 nanometer. For example, mixture of starch in water, mixture of albumin in water. Okay, milk is an example of a colloidal solution. See, what are the properties of colloidal solution? See, colloidal solution, first of all I told you, it is a heterogeneous mixture. Particles cannot be seen by naked eyes. You can't see the particles of even though it is a heterogeneous mixture, you can't see by its naked eyes. So solid particles cannot be distinguished by filtration. So you cannot filter. Take that colloidal solution, use a normal filter paper and try to filter it. You cannot filter it there. So particles scatter the beam of light passing through it. That is, take in one beaker colloidal solution, let us say milk or albumin salt or a starch salt. Allow the source of light to pass through it. So path of the light ray is visible due to scattering effect. That effect is what we call the Tyndall effect. We will learn in the next part of this. So that's about the colloidal solution. Another one is the suspension. So suspension is what? Suspension is also heterogeneous mixture in which the particle size will be more than 1000 nanometer. So in case of true solution, particle size will be less than 1 nanometer. In case of colloidal solution, the particle size will be in between 1 to 1000 nanometer, whereas in case of suspension, particle size will be more than 1000 nanometer. Okay, what are the properties of this suspension? Suspension is, as I told you, heterogeneous mixture it is. The particles can be seen by naked eyes. The solid particles can be separated by filtration. Solid particles settle down and the particles scatter a beam of light passing through that, and the path of the light is also visible there. See, mud is there. Mud you add into a beaker which contain water, mud solution you prepare. That's not a solution, it is a suspension it is. So chickpeas you add into water, so mix it. So that is a heterogeneous mixture. So particles are going to settle down. If you keep it for some time, particles settle down. Whereas in case of salt solution or in salt solution or sugar solution, particles do not settle even if we keep it for years together. But here the particles will settle down if we keep it for some time. So that is water suspension. Mud and water, chalk-piece water is example for that. So if you take arrange like this, the filter stand, okay, we have a funnel, take suspension in that, and mixture of mud and water or chalk-piece powder and water, and keep a filter paper here, add into that, filter it, try to filter it. So you will have there this water passing through that filter paper, so collected here as filtrate, and residue is obtained on the filter paper. Okay, you take in a beaker mud and water mixture or chalk-piece powder mixture, keep it for some time, the particles are going to slowly settle down like this. Okay, so in case of suspension, in case of this particle, when a source of light is allowed to pass through it, little bit the path of the light ray is visible clearly. So these are the things which we should know about the suspension there. Tyndall effect. We come across, I told you that the word Tyndall effect there. Take a colloidal solution in a beaker like this. Take in a glass jar or a beaker. Allow source of light to pass through it. When source of light is allowed to pass through it, path of the light ray is visible. You can see their path of the light ray is visible. So this is what the phenomenon, what we call the Tyndall effect. It is the scientist by name Tyndall who could discover that, so known as a Tyndall effect it is. You might have seen when the sunrise is there, the sunlight pass through windows in a dark room. Okay, what happens there? So you might have seen the light rays, how they are entering. Path of that light ray is visible because the dust particles which are present, scatters the light. It's because of that the path of the light ray is visible there. So this is what the phenomenon Tyndall effect. Source of light when it is allowed to pass through the solution, path of the light is clearly visible. That is known as Tyndall effect. So for example, take in a beaker colloidal solution, path of light is allowed to pass through it, visible clearly. So take like this in a beaker, the path of the light ray is going to be visible clearly. So like this it is. So Tyndall effect can be observed in our surrounding like this. Okay, saturated solution. What do we mean by saturated solution? Saturated solution is the one in which maximum amount of substance is dissolved in a given amount of solvent at a given temperature. It is a solution in which can dissolve more amount of solute at a given temperature. Maximum you dissolve, some more amount if you add it, that will not be dissolved there. So that is what we call the saturated solution. We come across the term called as the solubility. Often we use this solubility of gas in water, solubility of salt in water, solubility of solid in water like that. What is solubility? Solubility is a solubility of a substance is the amount of solute present in a saturated solution of the substance. Okay, so amount of substance present in a solution is nothing but solubility it is. Okay, unsaturated solution. We come across the word unsaturated solution. Unsaturated solution is a solution in which any amount less than that of this solute present in the saturated solution. That's what we call the unsaturated solution. So there may be capacity of dissolving 30 gram in let us say about 100 ml of water. So maximum 30 gram can be dissolved there. So in case of unsaturated solution, any amount less than 30 grams, if it is dissolved in water, then it is going to be unsaturated solution. Okay, right. So preparation of this saturated solution can be done like that. Take a beaker, in that you take about 50 ml of water or 100 ml of water, try to dissolve maximum amount of salt or sugar in it, so that at a given temperature maximum amount of solute is going to be dissolved, then that is going to be saturated solution. We come across the word concentration of the solution. What do I mean by concentration of the solution? So concentration of the solution is nothing but amount of a solute present in a given amount of solvent or in a solution. There are different methods of expressing concentration of the solution there, which we are expected to know it there. So concentration of solution is nothing but amount of solute present in a given amount of a solvent or amount of solute present in a given amount of a solvent. Okay, there are different ways of expressing concentration of the solution. Mass percentage we call it there. Volume percentage we call it. What is mass percentage? Mass by mass percentage or mass percentage we call it. The amount of the mass of the substance present per 100 parts of total mass of the solution is called as the mass percentage, or simply we call it mass by mass percentage or mass percentage we call it. So mass of solute divided by mass of solution into 100 it is. That's what we call the mass percentage. So mass by volume percentage. Take some mass of substance, dissolve in certain volume of solvent. That's what mass by volume percentage is. Mass of the solute present in given volume of solution. So calculate for 100. That will be nothing but a mass by volume percentage. It is the mass of substance present per 100 parts of total volume of the solution. That's what we call it. For example, you dissolve 10 gram of sugar in 100 ml of water. So that's how the mass by volume percentage is expressed. Separation of mixture. See, you have the mixture, homogeneous mixture and heterogeneous mixtures there. How to separate these mixtures we are expected to know it there. So there are some methods by which the mixture of separation can be done there, separating the components of mixture there, okay, as individual components there. These are the methods which are used to separate the mixture. One is the evaporation, another is the centrifugation, another is the decantation, sublimation, centrifugation, chromatography, distillation, fractional distillation. So these are the methods by which we can separate the mixtures. So let us see one by one these separation mixtures. One is what we call as the evaporation. So evaporation is a process in which the volatile component, so method used for separating volatile component from non-volatile component by heating the mixture there. Okay, you have some amount of water, you have the water. Okay, so in that what we do is you want to separate from this salt solution. Water is to be separated there. Heat that salt solution so that water get evaporate, salt will be remain. That method of separation is what we call the evaporation. It is. So ink is a mixture of like that we can find there. So ink is a mixture of dye and water. So those can be separated, heat it. So water get evaporate, dye remains on the dish. You take in a dish the water and ink. So ink mixture you take it. So what happens when you heat it? So water get evaporate. Only the colored dye is going to be remain on that dish, the surface of the dish. So this is what we call the evaporation, which is used to separate volatile component from the non-volatile component. The experimental arrangement can be done like this. Take a dish like this, keep it on a wire glass, burner is there, heat it with the help of that. So mixture of salt and water you take it there. So when you heat it, so water get evaporate and salt remains on this watch glass. or this dish. That's how separation can be done. Since water is volatile, salt is not a volatile, so separation of these two can be done by this evaporation method. Another one is the centrifugation. It is. So what is centrifugation? Let us see that. The method of separating denser particles from the lighter particles from the mixture using centrifuge machine. There will be centrifuge machine, so by which you can separate. You might have seen in the home the milk separated or cream is obtained, that you might have seen. On the same principle, the centrifuge machines will also be working there. So centrifuge machine, you can see in the picture there. There are two types of centrifuge machine. One is the hand one. If using hand, we can centrifuge it. What we will have to do now? There will be centrifuge tubes like this there. Okay, place it like this, and in that you will have to take the components which are to be separated there. So separated and rotate this, so that after some time some particles are going to be settled down, and the other particles will be in the above part there. Decant that you can separate out there. So electrical one is also there. With the help of electricity supply, you can also separate that one. So this is also hand only. Electric centrifuge machine will also be there. So especially in the research laboratories, and so to settle the precipitate, and even in the laboratory we can use that to settle the precipitate. These centrifuge machines can be used. Decantation. So decantation, what is decantation? This is a method used for separating a mixture of immiscible components. Liquids separates into different layers by their density. So for example, you have a mixture of kerosene and oil there. Kerosene and oil mixture can be separated by this method. You have a mixture of kerosene and oil. So take a separating funnel. So shake it well and keep it for some time. So the components will be separated like this. In picture I shall show you that. You have a mixture. This is what we call it is a separating funnel. We call this one as a separating funnel. There will be a knob here. There is one arrangement here to introduce that mixture, and add a mixture of kerosene and water there. So they will be get separated there. They will be get separated. So lighter one will be up and heavier one will be down. And open this knob. So slowly that can be removed from that. Okay. So up to that we can release, and once that kerosene part comes there, we can stop it. That's how the kerosene and water can be separated by this process called the decantation. So using separating funnel, decantation can be done there. Another one is a sublimation. You know that sublimation is a process it is in which the component, one of the component get sublime, convert directly from solid into gaseous form there. Suppose you have mixed some component with other component. Of the two components, one of the component is undergoing the sublimation and another one do not undergo sublimation there. So in that case, this method will be helpful for us. Okay. For example, you have mixed common salt with the ammonium chloride. Ammonium chloride. You want to separate ammonium chloride from the common salt. So for that, the sublimation method can be used there. This is a method used for separating a mixture of a sublimable component from non-sublimable component by heating the mixture. Arrangement is like this. So let us say you have the mixture of common salt and ammonium chloride. Take that in a china dish like this. Keep a funnel inverted position like this. Put a cotton here just to prevent the escape of these gases which are produced there, and heat it with the help of burner. So china dish, in that you have taken mixture of ammonium chloride and common salt there. Heat it with the help of mixture. After some time, when out of these two, ammonium chloride